Hey guys, welcome back. So today's gonna be our first day of doing class or a little bit differently. So today what we're gonna be talking about is we're gonna be talking about data structures. We're gonna be talking about three main data structures. They're a list, a stack, and a queue. Now just before school got suspended, we kind of went over these very briefly. So what I'm gonna do is I'm gonna go over them in a little bit more detail here, and I'm gonna give you guys an assignment to do with them. This first assignment is not gonna involve any programming. It's gonna be involving finding some real life applications and for you drawing it out on paper. Now to hand in this assignment, what I want you to do is I want you to take a picture of it or do it on Microsoft Word, do it on Paint, however you want, just to show me the difference between these type of data structures. So to put it very simply, data structure is just a way to hold data. All right, so we've talked about arrays, we've talked about two-dimensional arrays. Now what we're going to do is we're going to start to talk about um, stacks, queues, and lists. So the first thing we're going to do is we're going to talk about a list. Now, what is a list? Very simply, a list is kind of like an array, but it can be dynamically created. So what does that mean? It means that an array, when you make it, you have to define how large it is. Whereas a list, you can say it's a size 1 or size 2. But then we can add things to it and it can become as big or as small as you need it. An array, let's say we had 50 items, we'd say array at 50, make an array of size 50. Then let's say we needed to add a 51st item, we'd have to make a whole new array, copy those first 50 elements into that new array, and then add the new element that we want. A list, we would simply just add one to it. So arrays are great. They're useful when you have a defined amount of items you're going to need, but if you don't know exactly how many items you're going to need, or if you need to add and remove items as you go, a list is the way to go. All right, it's nice, it works well. So today what we're going to do is we're going to talk about how it works. Then tomorrow we're going to get into the coding. So what I have here is I have a little example. Now each of these little cells here with a number in it is an element in the list, we're going to say. Kind of like we show an array as a grid of these, we're going to show this as kind of like a list. So what we have is if we created a list of one element and we made an integer list, let's say we made it equal to 5. The first element in our list is going to be 5. Now let's say we wanted to make another one. All we would do is we would have to add to the list. Okay, now how this works is basically what happens is you link them, or they are linked automatically to each other. So in Visual Studios, they have an object called a list object, and it automatically just links it to it. So what it does here is it makes this thing in memory, oh, it's number 5. This one, let's say it has the value of 7. Now they might not be beside each other because we didn't create them at the exact same time. However, what it does is in memory it goes and says, okay, this is linked to this here. So it goes 5 and then 7. Let's say we call this list my num list. So it says my num list, and then let's say it will then link it in memory to the first value. So the first value is then linked to this 5. Okay, so this list here, my num list, says, okay, point to this 5 here in memory. That's where this is pointing to. And then this 5 says, well, my value is 5, but I also need to point to the next element in the list. So I'm going to say, okay, it's 7. So if I then all of a sudden make a new element, and let's say I call this 10, this might be in memory way over here. So what this one would then need to do is it would need to point to this object here. So we could have a bunch of stuff in memory somewhere else, but these items, these list items, will all be kept nicely, all right, in order. So it's just a way to keep items in order, all right? So a list is another way to hold information. So we can do it with integers, we can do it with doubles, we can do it with strings, we can do it with any type of object. Now we're going to start to talk about objects later on, but I want us to first work on some data structures. So a list, it can hold a defined amount of objects, but you can add and remove objects. We can take the first object off and then work with it. All right, so this is basically how a list works on the inside of it. Now again, if you guys have any questions whatsoever, please make sure you ask. All right, email, Google Hangouts, Google Meets, all that type of stuff. Send me some questions. So this is a list here. Also, so you guys know, there is more information on the Google Classroom. If you guys go down to the very bottom of it, So if we go down to the very bottom of the Google Classroom, the very first thing I gave you guys was this notes doc. And if we go all the way to the ends of the notes, what you're going to notice here is that it has information about lists. All right, and it gives you the code. So when we're making a list in C#, it's list, and then greater than, less than signs with the types. That'd be like int, double, string, whatever the case may be. And then here we give it the name, new list, and we give it the type. All right, to add, we go whatever our list is, dot add, and then in brackets the number we wanted or the object we wanted. And to remove it, we just go number list dot remove. So that is a list. Okay, we're going to practice them. We're going to be working with them a fair amount over the next 2 weeks. All right, so the next thing up you'll notice here is it's called a stack. Now a stack, think of it like a stack of objects that you may have. Okay, so a list points in different places here. Now for a stack, what we might have here is we might have this 5. Let's just scroll down here a little bit. So now we're going to work on a stack. All right, so I'll go down here and we'll say a stack. What does a stack look like? So let's say here I have this 5. This is the first number that I want it to have. Then I have another number, and let's say I give it number 6. All right, what this data structure does is it puts the 6 on top of the 5. So it could use a list, it could use an array, it could use a bunch of different things. Most of the time it uses a list, all right? But you could make one of these an array, but it wouldn't be as nice, I guess. All right, so what you're going to have here is you're going to have the list, or you're going to have the first item. It points to this item here. Then if we make another one, boom, we put it into here. So this could be a 2, and let's add one more. So this would be a stack of size 4. All right, now it's just one on top of the other. Now what this means here is if we try to get it off, so for a stack, it's a first in, last out type of data structure. So the first object in, so the first number we put in was 5. That's going to be the last number we get out. Because what happens is when we go, to put it on the stack, so to put on stack, we go push, and to get off, we go get off. It is a pop. So we push and we pop. So just to show you guys in the notes here, so if we look here, it talks about it here. We push the item on, and then we pop it off. All right. So push will add another item onto the stack, and pop will get it off. So if I did this stack.push, what it's going to give me is it's going to give me this first element here. It would give me this. It would return the 9. It would say, here you go. And if I popped off another one, it would give me the 2. Then I could push on the 9. I could go, oh, hey, you know what? I want a new one altogether. And this is going to be a 5, and I put it there. Well, then I pop this one off. And then I'd have to pop this one off to get to my first one. So this is kind of like when you have a stack of dishes. If I took a bunch of plates and I made a big stack of them, I wouldn't just take off the bottom plate. If I did that, all the plates would just fall and break. So what you do is you put on the top plate, then when you wash them, you take that top plate off. All right, it's like when we have a stack of anything. All right, you take the top part off and then you work your way down to the bottom. The last type of data structure that we have is we have a queue. All right, now a queue you guys have dealt with a fair amount in your life. You may not have known it, but you have. So here, this is a first in, first out data structure. And to add to the queue, we do on queue, and to remove an item, dequeue. All right, not the ice cream, even though I love it. So what we're going to do here is a queue. How it works very simply is, let's go to another page. Let's clean off this page. If I want a queue, what happens is I take my first element and I put it in. You can think of it as in the line. So the first element goes in, and then the second element goes in. Even do it like this here. So a 3. And then my third element goes in. Let's say this is a 2. All right. Now, when I dequeue it, or take an element out of the stack, I'm going to the first one. All right. So this is known as a first in, first out. Now, an example of a stack, or a queue, sorry, where it would be used is, think any line that you've ever waited in. If you've ever waited to get into the Bomber game, It's not the last person in, it's not the first person in that's the last one out. All right, the first person in line gets to go through security first. When you're waiting at a bank, the first person in line gets to get into their see the teller first. All right, first person in line gets the first service. So a queue is simply just a line as we would know it. You guys have been working with these lines and living with lines since kindergarten. All right, the first kid in the line would be the first one in the classroom. So that is our stack, that's our queue, that's our list. So those are the three types of data structures. Now, what I want you guys to do is after you've watched this video, I want you to go to the notes that are in the classroom, unless you've printed these off already. And I just want you to read through these notes again, all right? Just the last 2 pages here about list, stack, and queue. What I'm going to be doing is I'm going to be posting an assignment. It will be your assignment 1 will be called Data Structures 1. And it's very simple. You are going to have to give me some examples in the real world where you would find a stack, where you'd find a queue, where you would find a list. You also have to tell me why you chose a list, a stack, or a queue. Okay. Now, just some housekeeping items so you guys are aware. Starting next week, every Tuesday, I'm going to have a Google Meet with you guys. I don't know exactly what time I'm going to have it with you guys from. I'm thinking from like 9:30 to 10:30. I'll set up a Google Classroom. I'm going to invite you guys all. If you can come, great. If you can't, don't worry about it. I'll have it open for about an hour. And what we'll do is you guys can come in, you can ask each other questions, you can ask me questions. If you just want to talk, see each other's faces, all that type of stuff, I'll be open for that. It's not mandatory, but it's a great way for you guys to connect with each other, to connect with me, and also to ask any questions face to face that you may have. Also note that if you guys are having trouble with any of these assignments or any of these questions, feel free to send me an email and say, hey, Mr. David, I would like some more help. Could we do like a Google Meet? Could we do a Google Hangout? Could you help me? I'd be more than willing to do that with you guys. All right. So please make sure that you guys talk to me. You guys let me know how it's going. And we keep on working hard. As you guys know, your report cards are coming out in the next couple weeks. So I hope you guys are ready for that. Also remember, you're still expected to do work no matter what your mark is. So yeah, if you have any questions, please make sure you contact me. I'm always available for you guys. I will typically be online from 9 till 12 and from 1 to 4. So if you guys have questions, email me then. If you have a question that you're like, it's midnight and you're working on stuff, feel free to email me. I probably won't get back to you until 9, but who knows? All right. If it's in the evening, if I have my phone on and I'm near it, I'll probably answer it for you guys. So feel free to email me, feel free to chat, all that type of stuff. Yeah, so stacks, queues, lists. Thank you for watching the video, and make sure you guys do the assignment. Tomorrow, we're going to start to get into coding, stack, queue, and a list, and how they work. Just so you guys have an idea of what's going to happen, not only starting next week or kind of this week, we're going to have Google Meets, but also on Monday and Tuesday, I'm going to probably give you guys some instruction, and then I'm going to give you guys a bunch of mini assignments to work on for the rest of the week that will be due on that Friday. After you guys have done mini assignments for the topic, then what will happen is you guys will get an actual assignment that you'll be expected to code. All right. Now I know some of you might have trouble getting Visual C# on your computer. That's okay. You can use the online compiler that I've sent you guys. If you'd rather use a different language like JavaScript and you're comfortable with it and you find that easier, by all means you can do that also. I'm still looking for some good online stuff that we can use. If you don't have access to online, to computers or compilers that can run this stuff, I am still looking for options to help you guys out. Just try your best. I may get you guys to write code by hand and submit it that way. But yeah, so have a great night, guys. Have a great day. Make sure you guys are working hard, and I will talk to you guys again later. All right. Thank you, guys. Bye.